Hello everyone. Today we're going to learn how to draw Lewis structures. Lewis structures are diagrams that show how atoms bond together using valence electrons. By the end of this lesson, you'll know how to count valence electrons, draw bonds, satisfy the octet rule, and check formal charges. Example 1. CH4, methane. Let's start with CH4. The first step is to count the valence electrons. Carbon has 4 valence electrons. Hydrogen has 1 valence electron. And there are 4 hydrogen atoms. So the total number of valence electrons is 4 plus 1 times 4 equals 8 valence electrons. Next, choose the central atom. The central atom is usually the one with the lowest electronegativity, except hydrogen, and the one that forms the most bonds. In this case, that's carbon. Place carbon in the middle and arrange the 4 hydrogen atoms around it. Now connect each hydrogen to carbon with a single bond. Each single bond contains 2 electrons. Since there are 4 single bonds, that's 4 times 2 equals 8 electrons. Hydrogen follows the duet rule, meaning it only needs 2 electrons, while carbon follows the octet rule and has 8 electrons around it. Since we've used all 8 valence electrons, and every atom has the correct number of electrons, this is the correct Lewis structure for CH4. Example 2. H2O, water. Now let's draw the Lewis structure for H2O. First, count the valence electrons. Oxygen has 6 valence electrons. Hydrogen has 1 valence electron, and there are 2 hydrogens. So the total is 6 plus 1 times 2 equals 8 valence electrons. Oxygen is the central atom because hydrogen can only form 1 bond. Connect each hydrogen to oxygen with a single bond. Those 2 bonds use 4 electrons, leaving 4 electrons remaining. Place those remaining electrons as 2 lone pairs on the oxygen atom. Now oxygen has 8 electrons around it, satisfying the octet rule, and each hydrogen has 2 electrons, satisfying the duet rule. This is the correct Lewis structure for water. Example 3. SO4, 2 minus, sulfate ion. Our final example is the sulfate ion, SO4, 2 minus. First, count the valence electrons. Sulfur has 6 valence electrons. Oxygen has 6 valence electrons, and there are 4 oxygen atoms. The ion has a 2 minus charge, meaning we add 2 extra electrons. So the total is 6 plus 6 times 4 plus 2 equals 32 valence electrons. Sulfur is the central atom because it can form multiple bonds. Connect sulfur to each oxygen using single bonds. Complete the octets of all 4 oxygen atoms with lone pairs. If you count every electron, you'll find there are 32 electrons. So the electron count is correct. However, we still need to check the formal charges, with only single bonds. Sulfur has a formal charge of +2. Each oxygen has a formal charge of -1, although the total charge is still -2. This arrangement isn't the most stable, because the formal charges are larger than necessary. To reduce the formal charges, convert 2 of the sulfur-oxygen single bonds into double bonds. Now, sulfur has a formal charge of 0. The two oxygens with double bonds each have a formal charge of 0. The two oxygens with single bonds each have a formal charge of -1. Adding those together gives 0 plus 0 plus 0 plus -1 plus -1 equals -2, which matches the overall charge of the sulfate ion. Your final answer would be S double bond. Doesn't matter where you put it, but 2 double bonds with your no selections shown, and that's to make it. This is your SO for -2. Thank you for watching. Like and subscribe.